This is Mission Control Houston. Good morning. Today is September 24th, 2019. Right now you're getting a live view of the Yoshinobu Launch Complex. Sitting on the pad of Site 2 of the Launch Complex is the H-2 transfer vehicle called HTV on its 8th mission, HTV-8, sitting on top of an H-IIB rocket. The Yoshinobu Launch Complex is in Tanegashima, a southern island just south of the main island of Japan and the southern island of Kyushu. Right now we're counting down to a launch at 11:05 a.m. Central Time on September 24th, 1:05 a.m. Japan time over in Tanegashima. Here's a live look at the H-2B rocket. Again, on top is the HTV-8. Inside HTV-8 is about 4 tons of supplies, cargo, food, and experiments. Again, we're counting down to a launch at 11:05 a.m. Central Time. Over at the Takasaki Range Control Center, JAXA and Mitsubishi Heavy personnel looking after the launch of the rocket, tracking down for that countdown. Here in Mission Control Houston, good report so far as we're counting down to that launch. This is a live view from Mission Control Houston in Houston, Texas. The International Space Station Flight Control Room now led by Flight Director Greg Whitney. Visiting vehicle officers in the room communicating with HTV flight controllers over in Tsukuba, Japan. The Tanegashima Space Center, just south of the main island of Japan, but towards the center. HTV flight controllers will take over shortly after launch and see through the vehicle's trajectory to meet up with the ultimate destination, the International Space Station, controlled from this view right here. Again, everything on track for that launch on time, 11:05 a.m. Central Time, 1:05 a.m. September 25th, out of the pad at the Yoshinobu Launch Complex. Getting a good look at the H-2B rocket here. The H-2B will be carrying the 4-ton spacecraft into orbit. It'll be about a 15-minute ascent before the HTV is separated from the rocket. You can see the 4 strap-on boosters at the bottom of the rocket. That'll help with the initial lift. Those solid rocket boosters will burn for nearly 2 minutes, about 1 minute 54 seconds before they are separated. And that core stage that contains liquid fuel, liquid hydrogen, and liquid oxygen will continue to burn for 5 minutes and 47 seconds total through the first stage of the vehicle's travel to low Earth orbit. You can see a sort of exploded view here. Again, that first stage burns for the first 5 minutes 47 seconds. You can see the payload fairing at the very top. That will separate at about 3 minutes 40 seconds. And the HTV in the second stage will continue to burn after that first stage separates for another almost 8 minutes. Again, about 4 tons of cargo inside the Kunotari, or White Stork, the name of the H-II transfer vehicle that will be launching here in just under 30 minutes. You can see the exploded view of the HTV here. Inside the pressurized logistics carrier is about over 5,000 pounds of cargo, and in the unpressurized segment is just over 3,000 pounds of the lithium-ion batteries and associated adapter plates that'll be part of a series of upgrades to replace lithium-ion, the aging nickel-hydrogen batteries that are on the outside of the station, and store the power provided by the station's solar arrays, and be replaced with the newer lithium-ion batteries. You can see the exposed pallet is actually accessible once HTV is docked to the International Space Station. It's accessible robotically. Actually, towards the top of this view, you can see where that grapple fixture is, where the robotic arm will actually pull the pallet and the lithium-ion batteries out from the unpressurized logistics module. The avionics and propulsion module will carry the HTV throughout its flight, and on the pressurized logistics carrier, power will be provided by the solar arrays you can see actually throughout the vehicle. That'll provide power throughout its flight over the next 4 days until it rendezvous this Saturday, early in the morning Central Time. Again, those lithium-ion batteries will be a key component to upgrading the International Space Station. There are 6 lithium-ion batteries and associated adapter plates inside of that pallet in the unpressurized portion of the H-II transfer vehicle. Again, once it is docked to the International Space Station, we're looking for it to berth to the nadir port of the Harmony module. You can see from this configuration of the space station what it will look like soon. The HTV-8 at the very forward end on the Earth-facing side towards the bottom. The robotic arm will be able to pull out the pallet with the lithium-ion batteries and adapter plates from the unpressurized portion of the vehicle. There'll be sort of a handoff maneuver with the Japanese robotic arm that you can see towards the forward end of the screen and the forward end of the station on the exposed facility outside of the Japanese experiment module, the Kibo. There'll be sort of a handoff where the robotic arm will hand off to that exposed pallet robotic arm. Then the Canadarm2 will make its way to the truss segment where you can see it now in this view and pull over those lithium-ion batteries and the pallet. Because the lithium-ion batteries and the associated adapter plates are to be replacing the far port side of the International Space Station. From this view, the very far right. There'll be a series of spacewalks next month to complete the installation of that work. Some of the work will be done robotically to configure the work site for 2 spacewalking astronauts that will be performing the swap over a series of spacewalks again later in next month, October. V control and Takasaki range control over at the Tanegashima Space Center that are overseeing the launch. Everything still on track for a launch just 3 minutes from now. The International Space Station passing over the Atlantic Ocean, now crossing over into the continent of Africa, the southern border of the country of Liberia. It's on a northeastern track and will be located over Africa at the time of launch being over at the east at one of the southern islands of Japan. You can see there on this map. Everything's still on track from here in Mission Control Houston and out of the Range Control Center and HTV control. Less than 2 minutes to launch.
Followed by the pressurization of the liquid oxygen and hydrogen systems of the second stage, and they are now complete.
フレームディフレクター冷却開始。
Cooling initiates at the flame deflector.
1 minute until launch. Everything looking good so far.
打ち上げ1分前です。
T-minus 1 minute.
30 seconds to launch. Again, the solid rocket boosters and that core stage, the first stage containing liquid fuel, will carry the rocket through the first 1 minute 54 seconds of its launch. Everything's still on track, 10 seconds to launch. Getting a good view of the engine underneath, now igniting.
全システム準備完了。
All systems are go.
メインエンジンスタート。
We have main engine ignition.
T0 and liftoff of the HTV-8 and the H-IIB rocket carrying its way 4 tons of cargo to the International Space Station.
8号機は2019年9月25日午前1時5分5秒に
Lighting up the night sky over southern Japan. Everything looking good through the flight so far.
Vehicle number 8 with dormitory on board from the JAXA Tanegashima.
Those 4 strap-on solid rocket boosters will carry the vehicle through the first 1 minute 54 seconds of the launch.
打ち上げ以降ロケットの管制は吉野発射管制塔から竹崎総合司令塔に引き継がれています。
Following liftoff, the operation control of the launch vehicle has been switched from the blockhouse to the range control center.
ロケットは現在徐々に南東方向の太平洋上へ飛行しています。
Now 1 minute into the flight. Twenty more seconds before those solid rocket boosters burn out. Everything looking good so far. The vehicle itself heading towards the southeast to get in the right phasing to meet up with the International Space Station. You can see the solid rocket boosters beginning to burn out. We should see them separate in pairs coming up here in just a few seconds. There's the first pair of solid rocket boosters separating. And the second pair. Now that core stage will continue to burn until 5 minutes 47 seconds into the flight, burning liquid fuel, liquid hydrogen, and liquid oxygen. Good confirmation of booster separation, 2 minutes 47 seconds into the flight, 3 minutes left of this first stage. Three minutes 47 seconds into the flight, everything looking good so far. That first stage will continue to burn for another 2 minutes. Four minutes 47 seconds into the flight, 1 minute left of this stage. Everything continued to be on track throughout the flight of the HTV today and the H-IIB rocket, performing nominally. Again, 5 minutes 47 seconds into the flight will be the cutoff of that first stage. It'll enter into a 7-second coast period before the first and second stage separates. Another 7 seconds until the second stage is ignited. Everything continuing to be on track. 5 minutes, 27 seconds into the flight, 20 more seconds of the first stage burning. Switching to animation right after the burnout of that first stage. And confirmation that that first stage did successfully cut off. Second stage burning now. First and second stages separated. This second stage will burn for well over 8 minutes, 8 minutes 19 seconds. It'll be just over 15 minutes until the HTV itself is inserted into a good orbit. Coming up on 7 minutes into the flight, everything looking good so far.